All right, today we're starting 3.6, implicit differentiation. Say that 5 times fast. All right, I really didn't think you would, but that'll work too. All right, first thing, let's start off, just quick refresher. Find dx dy for y equals 9x squared. Ready, set, done. What's dx dy stand for? It's the first derivative in respect to x. So what do you get? 18x. You guys are so used to we're just using y prime is 18x. Easy enough. Do you want to use this notation or stick with the y primes? All right. Now we're going to find the derivative for x squared plus y squared equals 9. What's different about this one? I have an x, I have a y, they're both squared. When I graph this is something we talked about in pre-calculus. We'd have to rearrange this and solve for y. Y equals, then I have to do what at the end? Square root. When I graph the first part, it's going to be something like that. Actually, when I graph the positive part, it looks like that. When I graph the negative part, it looks like that. That's the formula for a circle. What this is, I have x squared plus y squared equals 9. This is a circle with a radius of 3. Looking at the x squared plus y squared equals 9. We don't have the y by itself. We would have to solve for y, take square root, we end up with the plus minus. We would say that this equation defines y implicitly in terms of x. In order to solve these problems, we're going to find the derivative of both sides of the equation in respect to x. And we're going to treat y as a derivative of x. We're going to collect the terms with y prime on one side of the equation and then solve for y prime. All right, here's the equation. We need to find the equation of line that is tangent to the circle that we were talking about, x squared plus y squared equals 9 at the point of negative 2 square root of 5. I'm going to flip back for a quick second. So here's our circle. What was the number? 2 square, negative 2? All right. So there is a negative 2. There's a line that is tangent at that point. You have to remember from geometry, tangent is it's the perpendicular line from the radius to one point on the circle. So this line that touches the circle at exactly one point, right, it's negative 2 square root of 5. So that point, we need to find the derivative here. Problem is, on a normal problem, we can just take the derivative, and there's only one equation. Here, it could be down here, which means it would have to be at the second part of that equation, at the negative aspect. If it's up here, it's on the positive aspect. I don't want you to have to graph every single time to figure out what we're doing. So we're going to find the line that's tangent at that point. What we're going to do is we're going to find the derivative of each piece. You have to remember, when we first started talking about derivatives, if we had 4x squared plus 5x, you find the derivative of this plus the derivative of that, right? So we can do it piece by piece. What's the derivative in respect to x of x squared? 2x. The derivative of y squared in respect to x. It's not, you can't, there's no x, right? So what we write is plus, what would be the derivative if that was an x? 2y, y prime. Why? Because we're finding the derivative of 9. The derivative of 9 is 0. You with me? You could put this in parentheses, yeah. Or y prime is multiplying. All right? Because it's in respect of x. We don't have that x there. All right, now what we're going to do is we're going to solve for y prime. I'm going to move this over, and then I'm going to divide by the 2y. So I have y prime equals negative 2x over 2y, which is negative x over y. We still have at the point 2, negative 2, square root of 5. You don't really understand which part. What I did here, I moved the 2x to the other side, so minus 2x minus 2x. And then I divided everything by 2y. And then I simplified. I still need to solve the problem, though, at this point. What's this number stand for? X. So negative 2 over, this is your y. So it's 2 over square root of 5. That is your answer. So what we should do now would be 2 square root of 5 over 5. Then that's it. All right, we're going to take the derivative of 5x squared equals 3y squared. I can rearrange it to one side. It doesn't matter. It's just you're adding more steps. You want to become efficient. I have a y by itself. Eventually, you want to have y by itself. I'm going to take the derivative of this, which is 10x. The derivative of this, 6y, y prime. It doesn't matter if you want to put them in parentheses. A couple of you were saying put that one in parentheses. Now you need to get y prime by itself. Divide by 6y. If I divide by 6y, 10 over 6 is 5x over 3y is what y prime is. And that's your answer. All right, in the picture, this is how light passes through the lens of a surface. There's our tangent line, the curve of the surface, the point of entry. This is called the normal line. It would be from the radius to the tangent extended out. The law describes how the light changes direction as it enters a lens. I'm not going to sit and read everything. You guys can read yourselves. But in other words, the big thing I want you to know about is that normal line. Normal is the perpendicular line to the tangent. When we're talking about equations, how do you find perpendicularity? What do you mean upside down? Upside down t, yeah, that's opposite reciprocal slopes.
Negative 2 is 1/2.
All these pictures. All right, I have y cubed plus x cubed plus y cubed minus 9xy equals 0. If I graph this, this is what it looks like. Like a roller coaster, a scary roller coaster at that. I don't like that right there. There's the tangent line. There's the normal line. We want to find the point, or find out that 2, 4 is on this curve. And we're going to find the tangent and normal to that curve. So what we have to do is find the derivatives. What's the derivative of x cubed? 3x squared. What's the derivative of y cubed? 3y squared y prime minus, all right, I have negative 9xy. What's happening there?
It's got 2 in here. Got 2. It's here on 0.
Being multiplied, which is your product rule. All right, if I take the derivative, I'm going to have the 9. X, the derivative of y is y prime. Minus 9, the derivative of x is 1 times by y. And the derivative of 0 is 0. All right, I'm going to combine my like terms. I'm going to put this one and this one over here. I'm going to put these two together and factor out a y. So I have y prime times 3y squared minus 9x. I'm going to equals, I'm going to throw these two to the other side. I took the y prime out of the, right there. Negative 3x squared plus 9y. Divide everything by that. Y prime equals negative 3x squared plus 9y all over 3y squared minus 9x. I still have to put in the point 2, 4. So put in the 2 for x, the y for 4.